Hey guys, today we're going to look at lesson 10.2, graphing linear equations. Before we start, let's do a little bit of review. This is something that we did earlier in the school year where we were substituting in values for variables. So what we need to do is look at the expression that we're given and determine what value goes where. So when we have 3n minus p, I'm going to say, okay, n gets replaced with a 3. And then p gets replaced with a 2. So I'm going to have, it's going to look like this, 3, and I always use parentheses. I'm basically taking out the n and the p and substituting in what we have for values for n and p. We said n was 3. We said that p is 2. So if I continue with that, I would get 9 minus 2, and that is 7. So for this one, I'd be taking out n, I'd be taking out p, and I'd be taking out, and I'd be taking out s. So substituting in what I know that n was 3, I know that p was 2, p went over here, and then s, to make that be orange, s is 4. So now I'm going to have 3 minus 4 plus 4. Order of operations says that I do addition and subtraction in order from left to right, so it'd be -1 plus 4, and then -1 plus 4 is 3. All right. So we are going to start by determining whether each ordered pair is a solution. Now what we're going to do is have to recall that the first value is x and the second one is y. I always write x and y over my values so that I remember where I'm putting each value. So for this first one, I have x is 4 and y is 11. So I'm going to take this equation and I'm going to rewrite it first, and then I'm going to substitute in x to the x spot and 11 to the y spot. So I'm going to get 11 equals 3 times 4 minus 1. So I'm going to have 11 equals 12 minus 1, 11 equals 11. That's a true statement. Those are the same numbers, so I can say that this is a solution. It makes a true statement. Now we have 7 and 12. So I'm going to rewrite my equation. And 7 is going to go in for x, 12 is going to go in for y. 12 equals 3 times 7 minus 1. So I would get 12 equals 21 minus 1, and 12 equals 20. Well, that's not true. 12 and 20 are not the same number. So this is not true, and I would say it is not a solution. Final problem, we have 23, or excuse me, sorry, I didn't write my equation. Y equals 3x minus 1. I think it's good to always rewrite your equation so that you're not forgetting what you started with. That's a bad arrow. I'll try that again. There we go. So I'm going to get 23 equals 3 times 17 minus 1. So on the left-hand side, I can't simplify 23, but if I do 3 times 17, I should get 51 minus 1. 23 equals 50, and those are not the same number, so this would also not be a solution. So we can find solutions of an equation by making a table. And we're going to choose different values for x and substitute them into the equation. Here we were given values that we had to substitute in, but we can actually have some freedom when we're given an equation to pick values of x and substitute them in. So let's try it. Make a table to find 3 solutions of y equals x plus 5. So I'm going to make a table with x over here. My equation is going to go in the middle. and I'm going to have y over here. So now the cool thing is I can pick any value of x that I want. I always like picking 0. I think 0 is a nice easy number to substitute in. And that's going in for the x. I don't know what y is though, so I'm leaving y equals. So I've got y equals 0 plus 5, and that would give me 5. Okay, so there's 1. Let me pick another value. I'll pick 1. So I've got y equals 1 plus 5, so y equals 6. All right, there's another value. I need one more. Let's pick a -1 here. I'm going to pick -3 just because I can. Y equals -3 plus 5. And that would give me 2. So these are not solutions though. This is just the table showing our work. It says to find 3 solutions. So to write them as solutions, we need to write them as an ordered pair. Remember, x always goes first, so it's going to be 0, 5. It's going to be 1, 6. And it's going to be -3, 2. So these would be my 3 solutions. All right, let's try another one. My normal values that I plug in are -1, 0, and 1. So I'm going to do that. Y equals -3 times -1. I like these values because they're all relatively small, and so they're a little bit easier to plug in than, say, if I wanted to plug in like 27. That is doable, but it's just a bigger value. So if I do -3 times -1, I get +3. So my first solution would be -1, 3. Next I have y equals -3 times 0. And I've got y equals 0. Finally, oh, and let me write that ordered pair solution. Remember, do you remember what this special point is called when it's 0, 0? Y equals 3, 1. 3 times 1. Oops, I didn't mean to draw that line. So y equals 3. All right, so here would be my 3 solutions. Now, you could plug in different values for x and you would get different answers, but they should all match up. All right, so you try this one with y equals 9x minus 7. Pause the video and then come back and check your answers. Here are the answers that I came up with. I just used my values of -1, 0, and 1. Again, you might have used different values. And if you aren't sure if you got your values correct, you can send those to me and I would be happy to check them. But if you used -1, 0, and 1 for x and you got different y values, let me know and we can find where you made a mistake. All right, so we are going to be graphing some linear equations. When we collect and organize all of the solutions to an equation, we get the graph of an equation. If the equation produces a straight line, then the equation is called a linear equation because it makes a line. So that's why that word line is in there, but it's pronounced linear. To graph a linear equation, we are going to pick 5 values of x to substitute into the equation. And this is very important. We are going to use 5. If you don't use 5, that's not enough. All right. Graph the linear equation. So I'm going to pick 5 values of x to substitute in. And I'm going to pick values that are pretty close to 0, and I'll show you why here in a minute. So these are kind of my standard values, -2, -1, 0, 1, and 2. I've got y equals x minus 1 and y. So y equals -2 minus 1, which would give me -3. Ah, I don't know how I did that. That was magic. Y equals -1 minus 1, -2. Y equals 0 minus 1, -1. Y equals 1 minus 1, 0. Y equals 2 minus 1, 1. All right, and so then if I write each of these as ordered pairs or as solutions, I've got -2, -3, and I can graph that. -2, -3. For my next one, I would have -1, -2. So that would go right here. For the next one, I would have 0, -1. That would go right here. And then I'd have 1, 0, which would go over 1 and up 0. And finally, I would have 2, 1. That would go right here. And this is a good way to check my work. Everything looks like it's in a straight line. So that means that I am doing something right. And I'm going to connect them with the line going through. If you're doing this on paper, you can use a straight edge. I do not have a straight edge on my computer, so that's pretty good actually, not too bad. But the other thing is make sure that you are putting these arrows at the end to show that this pattern continues even after we are done graphing. So for this one, we would have our table. And I'm going to have my linear equation in the middle. So when I would do y equals -2 times 2, sorry, -2, I'm substituting in -2, not +2 yet. I would get +4, sorry, +3, which is 7. Then I'd have y equals -2 times -1 plus 3. Well, this would give me 2 plus 3, which is 5. I'd get y equals -2 times 0 plus 3. That would give me 0 plus 3, which is 3. And you might start to see a pattern happening in the y values. And you might say, Ms. McFall, do I really have to make a table for all the values? And the answer is yes, because the table helps us organize our work. And it helps us make sure that we are not making a mistake up here, that we're continuing down here. Oops, I did it again. So this would give us -4 plus 3, which is -1. So now I'm going to start graphing points. I've got -2, 7. So that's left 2 and down 7. Oh no, up 7. Sorry, it's a +7. Left 2 and up 7. Then we'd have -1, 5, which would be left 1, up 5. And then we've got 0, 3. And then our next one is 1, 1. And so far, it looks like these are all lining up pretty nicely, so that's a good sign. And then we've got 2, -1. Last thing to do is connect them with a line. Not too bad. Again, you should use a straight edge to make sure that it stays nice and even. All right, last one. Try this in your notes and then come back and see how you did. So this is what you should have gotten. If you're using the same values that I do, these are the y values that you should have gotten, and then this is how they would graph. So I said that I was going to answer the question of why I use these values, but I want to know what you think. Why do you think we would use those values of -2, -1, 0, 1, and 2? Why wouldn't I use, say, 8 or -10? Why wouldn't I want to use those bigger values? All right, so that's what I've got for you today. Head on over to Google Classroom and check out your assignment for the day. Bye, guys.